Review assignment number 7. It's always best for you to do it first, then look at the solution. So here is the equation you're given. They said find the derivative of this. We're going to do it implicitly. So the derivative of y is 1, but it needs a hook y prime. The derivative of cosine is negative sine, but it needs a hook y prime. The derivative of 1x is 1, and the derivative of 1 is 0. Then we're going to factor out y prime. So if I factor out a y prime, I'm left with 1. If I factor out a y prime, I'm left with minus sine y. And then divide, and you have your answer. It's part A. Part B, write an equation for each vertical tangent. So, vertical tangent. So this means where the derivative is undefined. So in this case, a vertical tangent means where is this derivative undefined, okay? So just look at the denominator. Make it equal to 0 and solve it. So I'm going to add sine y. And then where on the unit circle is the y value 1? So it's at pi over 2. And you have your answer. So at pi over 2, you have a vertical tangent. Part C, do the second derivative. So we're going to have to do the quotient rule. That's the bottom times the derivative of the top minus the top times the derivative of the bottom. So the derivative of 1 is 0. Negative sine would be negative cosine, but it needs a hook y prime, and then the bottom squared. And then if you put it in terms of y, with 0 times anything is done, and a negative times a negative is also positive, and 1 times this becomes positive cosine y. Y prime is 1 over 1 minus sine y over 1 minus sine y squared. So plug that in for y prime, and then you have your answer. Next one. Number 2 on here. Calculator allowed. The number of gallons of a pollutant in a lake changes, and it gives you a derivative. So the rate of change is there. It's ugly, but the calculator doesn't care. That's gallons per day. It's good to know your units. Or T is in days. There are 50 gallons in the lake at time t equals 0. So the initial amount is 50 gallons. The lake is considered to be safe when it contains 40 gallons or less of pollutant. Is the amount of pollutant increasing at time t equals 9? So increasing is the derivative. So that's what we have. So I'm just going to plug in 9 and see if the answer is positive or negative with my calculator. So it's just plug. So I go 1 subtract 3. E is on the left. And then negative 0.2 and the square root of 9, just like that. And I get negative 0.646. So the question is it increasing or not? So the answer is it's decreasing. Because the derivative at 9 is less than 0 or it's negative. That's A. All right, I'm going to switch over here. B. For what value of T will the number of gallons of pollutant be a minimum? So for it to be a minimum, we need to, first of all, take the derivative equal to 0 with our calculator. So what's given is that. So we're going to go menu algebra solve. I don't need to find the derivative is what I'm looking at. So it's just taking that equation, 1 subtract 3e to the negative 0.2 and the square root of t. Make it equal to 0 comma t. And I get 30.173. We already know that when you plug in 9, the answer is negative, right? That was in part A. And so what would happen if I plug in a number bigger than that? Like if I go back up here, see where I plugged in 9? Like let's say I plugged in 40. The answer is positive. So what do we have here? Is we have a minimum there. So if I read the question again, it says, for a value, will there be a minimum? And the answer at t equals 30.173 will be a minimum. And we showed, right, why it's a minimum. Part C. Is the lake safe when the number of gallons of pollutant is at its minimum? Yes, because it's safe when it's 40 or less. Oh, that's the rate. So, if I want to know at this value how much there is, we actually have to integrate the rate. So, in the question it says that there are 50 gallons to begin with. That's the starting value. And then I want to integrate from 0 to 30.173, the derivative. This will tell me the starting value, and then when I go up to this, how much there is. This tells me the increase or decrease from 50 up to that number. So there's the setup. And again, it goes from 0 to 30.173. And again, I type in 1 subtract 3e to the negative 0.2 square root of t dt. And I get 35.104. That is less than 40, right? So it is safe. Next, let's answer this. Hello? I need 90. Okay, bye. All right. Part D says an investigator used the tangent line to approximate at 0. So for a tangent line, t equals 0. We know 50 would be the y value, if you like, or p at t. And then the slope, we'd have to find the plug in 0 into the derivative. So this equation it's actually pretty simple. If I plug in 0 to know what the slope is, e to the 0 is 1. Just 1 take away 3, which is negative 2. So the line would be y equals negative 2. T minus 0, which we don't need, plus 50. So if I put it together, it'd just be negative 2t plus 50. And then it becomes safe when it's 40, right? So subtract 50, divide by -2, and I get 5. So in 5 days it'll be safe. So again, it'll be safe at 40. So we have a linear model, easier to work with, equal to 40. So approximately when will that equal 40? In about 5 days. And it's done. All right, next. A particle moves along the x-axis with velocity, and then it has different questions. Those, I think, are usually pretty basic questions because we've worked a bit on it. So we're given the velocity. It's one where we need a calculator to work with it. Oop, there it is. So the first question is, what's the acceleration at 3? How do you find acceleration? Is to take the derivative at 3 from there. So how do I take the derivative at 3? Oop, there's the shine off. So I'm going to go menu calculus, derivative at a point. It's fine. We can use x or t. I'll use t. And the value is at 3. And then I type in -1, subtract 3e to the -0.2 and the square root of t. And I get 0.122. Make sure that's right. Oh, it says no calculator. Well, then I can't do that. So let's try it again. So with no calculator, the derivative of -1 is 0. The derivative of e is I copy it. And then the hook, the derivative of 1 subtract t is -1, because the derivative of -t is -1. Then plug in 3 and you just leave the answer. So 1 take away. I wouldn't even mess with it. And there's the answer. So it's -e to the -2. But that's perfect. Next one. Ask for the speed of the particle at 3. So for the speed of a particle, we haven't talked as much about this. I need to know two things. So I need to know the velocity and the acceleration. So I already know the acceleration is a negative value, because e to the -2 is a positive number, and that makes it negative. If these signs match, we'll know if the speed is increasing or decreasing. So the velocity, plug in again, 1 take away 2, or 3. So if I went -1 plus this, that's a fraction that's smaller than 1. So this is also a negative answer. So see how they match? So if these signs match, the speed is increasing. And we're looking at both the velocity and acceleration that the signs match. If the signs match, it's increasing. If the signs match, then the speed is decreasing. Part C. Here. This was part A, part B, part C. Find all values of t at which the particle changes direction. So to know if it changes direction, we take the velocity equal to 0. And then we solve that. So I'm going to add 1. The only time that's equal to 1 is if the exponent is equal to 0, because e to the 0 equals 1. So if I solve it, add t, it's 1. So then when I look at this, if I plug in a number bigger than 1, it's going to be negative. But if I plug in a number like smaller than 1, like a half, it's going to be positive. So it changes direction at t equals 1. Part D. find the total distance from 0 to 3. So for the total distance, it changes at 1. So we need to know the distance from 0 to 1. Now we only have the velocity. So I need to integrate from 0 to 1, so it goes from 0 to 3. So I'm going to integrate the velocity. And then add, and now the integration, and it's the absolute value of this, from 1 to 3, because it'll be a negative answer because it's going the other direction. So if I integrate this, negative 1 is negative t. This has a hook that's negative, so it'll be negative e, 1 minus t, copying it from 0 to 1. It's the same thing. And then you just plug in. We don't need to simplify it. So I'm going to plug in 1. Subtract, plug in 0. E to the 0 is 1. Do the same thing here. So it's the absolute value of this. So plug in 3. Subtract, plug in 1. And then you have your answer. You don't need to simplify it. All right, turn the page. Let R be the shaded region in the first quadrant enclosed by the y-axis and the graphs of sine and cosine. I feel like we've done this one before. Good practice. Cosine starts at 1. Sine starts here at pi over 2. Kind of keeps going. Kind of keeps going. In terms of what's happening, it's this shaded area here. To find that area, it's top subtract bottom. Now, I need to know at what angle does sine equal cosine, and that angle is pi over 4. That's on the unit circle at root 2 over 2 and root 2 over 2. And that angle where they're both the same value is at pi over 4. So we're going to integrate from 0 to pi over 4, and it's top subtract bottom. So I need to integrate cosine. Now when you integrate sine, it's negative cosine, so a negative and a negative makes it plus. And then we plug in the top angle. Subtract the bottom. And that's a good answer. If you wanted to, which you don't, you can find the values on the unit circle. So this is 2 root 2 minus 1, or just root 2 minus 1 because the 2's cross out. And that's the area between cosine and sine. It says find the volume generated when it's revolved around the x-axis. So around the x-axis here, there's a space here. So I know it's going to have 2 radii, a big radius and a small radius. So the big radius is cosine minus 0, and the small one is sine minus 0. And it goes from 0 to pi over 4. We need to find the volume of it. Oh, and it says with calculator. So then you would type this in your calculator. I'll do it with you so you can see it. So that's pi, calculus, integrate from 0 to pi over 4. And then, what do we have? Cosine squared minus sine squared dx. That's what it would look like. It's always good to practice with your calculator. And I get 1.571 or 0. I was trying to figure out how to integrate it without the calculator. That's why I was looking around. One more. Find the volume whose cross sections cut by are perpendicular to the x. That means it's with the x. Are squares. So in order to do that, the formula for a square is you take the base and you square it. The base of that is always top subtract bottom. So in our picture, top subtract bottom. And then we square it. So we're going to integrate from 0 to pi over 4, cosine minus sine squared. No pi in front. We're not revolving and making a circle. And then use your calculator. So menu calculus, integrate from 0 to pi over 4 again. Parentheses, and then it's cosine minus sine. And then I square it, dx. And it should be 0.285. Perfect. All right. What do we got? Last one. The figure above shows the graph of a derivative. I might answer it right here. The domain of f is the set of all real numbers, so from -3 to 5. So at what values does it have a maximum? So for the derivative, it has a maximum when it goes from positive to negative. So that is a maximum. And that's it. There's no other positive to negative. So only at x equals -2. And you can say that the derivative changes from positive to negative. That's why you know. Where is there a minimum? So that's when it goes from negative to positive. So from negative to positive, the only one I see here is at 4, where it goes from bottom to top. And again, the derivative changes from what to make a minimum. From negative to positive. On what intervals is the graph concave up? So when I look at the derivative graph, it's concave up when it's increasing. So it's increasing from -1 to 1. It's also increasing from 3 to 5. That's because the derivative is increasing on those intervals. So when the derivative is increasing, that means concave up. Suppose f at 1 equals 0. Draw a sketch that shows the general shape of the graph of the function from 0 to 2. So at 0, at 1, the answer is 0. We know that at 1 might be a point of inflection. So this is decreasing. All of it. From 0 to 2, it's all negative. So it's all decreasing. And now what's the concavity like? So the first part is in. So first part is going to be concave up. So concave up. and decreasing. And then the next part is decreasing, which means it's concave down and decreasing. And so you have the general shape of the whole thing is decreasing because the whole part from 0 to 2 is below, it's negative. Increasing means concave up. After 1 to 2, it's concave down. So we went concave up, concave down, and made the general shape. That's it. Mr. G Math over and out. Great job. Reviewing calculus today. Over and out.